Put the forces in the cross, resolve the 8 Newton force, 8 cosine of 40, 8 sine of 40 going to the north. Find which is bigger, east or west. East is bigger. Make sure we put the forces nose to tail, the resultant will go in the opposite direction. Use Pythagoras' theorem, the resultant is 9.66 newtons. For part 1, the gradient is the acceleration, so minus 1.5 is the rise over run. The rise is minus 15, which means the velocity is 5 meters per second. Part 2, find the distance travelled. Find the area of the rectangle plus the area of the triangle is 50 plus 75, a total of 125 meters. Part 3, the distance travelled after 14 seconds is 145 meters. So the distance left is now 55 meters, which means the area of this triangle is 55. So 55 is a half times 5 times 10, giving us a time of 22 seconds, but the total time is 36 seconds. And we have 2250 newtons going forward. We have a resistance of 650. We've got the tensions, equal and opposite. We have 250 going against the trailer. We have mg acting downwards, reaction of the car, reaction of the trailer. We then use the whole system using F equals ma. Any force going with motion is positive, any force against motion is negative. We've given us an acceleration of 0.75 meters per second squared. We then look at the trailer. F equals ma, the tension is 850 newtons. I would draw a new diagram. There's no tension, no tow bar, so as a 250 newtons is a resistance force, it's a minus 250 will equal the mass times the acceleration. The new deceleration is 0.3125 meters per second squared, so U is 15, the final velocity is 0, the acceleration is minus 0.3125, find S. V squared equals U squared plus 2S, giving us an S of 360 meters. Number 4, variable acceleration. This is S. To find V, we differentiate. T cubed minus 6t squared. To find the acceleration, differentiate again. 3t squared minus 12t. Minimum velocity is when the acceleration is 0. So 3t squared minus 12t is 0, giving us 2 times t is 0 and t is 4. When t is 0, the velocity is 0. When t is 4, the velocity is minus 32 meters per second. You must check from our C1 if it is max or min. So find the second differential. So when we differentiate the velocity, we get the acceleration. So that's 3t squared minus 12t. d2v over dt squared is 6t minus 12. When t is 0, that gives us minus 12, which is max. When t is 4, it's plus 12, which is minimum. So that shows it is a minimum velocity. Even though it's 3 particles, your first diagram should only have particle A and particle B. Total momentum before equals total momentum after. Sub the values in carefully. Cancel out the m's. We end up with V equals minus U. We're looking at particles B and C. They coalesce, so they become a 6m afterwards. Put the x this way. Total momentum before is total momentum afterwards. X will be minus 3u. That's the velocity is minus 3u meters per second, which means in the opposite direction. So therefore the speed is 1 over 3u meters per second. You give a clear explanation. They are both travelling in the same direction. A has got a speed of u. The coalesced particles have a speed of a third u, so therefore they will never meet. Drawing your diagram, make sure you've got an mg here, 40 newtons going down this way, 10 newtons going right down the middle of this. We have tension going across this way. We have at the hinge here, we have an x force and a y force, with this angle here being 60 degrees. In order to find the tension, we must take moments about A. That eliminates the x and the y force. So we must get these forces at right angles. Get your angles correct. So that's 60, that's 30, which means we have 10 cosine of 30 going this way. We have 40 cosine of 30 here, and t cosine of 60 going this way. Remember, a moment is the force times the distance. A lot of people are forgetting to multiply by the distance. I think it's best to change the distance into meters. So we have the clockwise will equal anti-clockwise. 10 cosine of 30 times 0.15 plus the 40 cosine of 30 times 0.3 will equal t cosine of 60 times the 0.3. Rearrange, t should equal 77.9 newtons. We find the magnitude and direction of the reaction of the hinge. Resolve horizontally, t equals x, which means x is 77.9 newtons. Resolve vertically, y equals 10 plus 40, so y equals 50. Again, put them nose to tail, so the reaction force will go in the opposite direction. Using Pythagoras' theorem, we get 92.6 newtons. Work out this angle at an angle of 32.7 degrees above the horizontal.